Hello students, this is Dr. Diaz and I'm here to answer the question, do the elimination reactions always favor Zaitsev? We can say that they will normally favor the Zaitsev products, right? So we cannot say like they always will favor Zaitsev products. And why? Because we're talking about elimination reactions. If you ask me about E1, yes, E1 will always favor Zaitsev because we have carbocation over there. It's free, so we can attack any side. We don't have any hindrance, steric hindrance over here that will not allow this reaction happen. So in normal things, like here we have an E1 reaction. So in this, we could extract any proton over here. So you know how E1 works, right? So bromine will leave with the electrons over here, and this base will extract this proton over here, and the proton will leave behind the electrons, form a double bond. But I also can extract this proton over here, and this proton will leave behind the electrons forming this double bond over here. So, and as you can see over here, and these two carbons and this carbon have 1, 2 substitutes, and this second carbon here we have 1 substitute, right? So we have 1, 2, 3 substitutes, so we can call tri-substituted, right? Substituted. And here we have just this carbon here. We have just nothing because we have hydrogen, and here I have a methyl and a methyl, so it's 2 substitutions over here, so it's a di-substituted. And this, what you call Hoffman, because less substitute, Hoffman. And we have the Zaitsev, which have more substitute and is more stable. Okay, so, but now let's see what happened with E2, because with E2, you know, it's a concert, a reaction, so everything will happen at the same time. So sometimes Zaitsev rule will not work because let me just write down here. So in E2, Zaitsev is not always followed. So can you please tell me when they are not followed? So let's see over here, this case. I put this over here. So we have this this example here. I have a 2-methyl group over here, and I have a bromine over here. So, and I have the ethoxide over here. So bromine will leave with the electrons, and the ethoxide can attack this proton that will leave behind the electrons. So what you're gonna have here is this product here. And we can see that we have 1, 2, 3 substitutes because we have 3 methyl, right? So hydrogen is not substituted. So hydrogen, when we have a group that methyl or any kind or any other element, ethyl, propyl, any other group or atom, we call substitute. Hydrogen is not substitute. So less hydrogen shows that we have more substitute. Okay. So of course we have also, this is a beta carbon over here, right? So of course this methyl group has 3 hydrogen. I will just represent 1 here to show you the ethoxide extracting this proton over here. So what you're gonna have is this product over here. And here we can see that we have just two substitutions here. So we have here the Zaitsev, and here we have the Hoffman. And you're gonna say like, oh, okay, but you just said this Hoffman product can be the favor one, so the reaction could favor the Hoffman, and it will if, let's grab the same example. Okay, so I have the R over here, and I have, now I will choose a buck base. So butoxide potassium over here. So what's gonna happen here? Now we have a sterically hindered base. This is the base that I showed you at the whiteboard. Remember that we have 3 methyl groups, and that is the butoxide over here. So we have a very strong base, but we have large groups around. So we have sterically hindered. So what's gonna happen here? Look at the same hydrogens that we have here. Remember that I put over here one, and the other one I'm gonna use the green over here. So if you look here, which one is best to be attacked by a buck base? The one that we have less steric here, because here we're gonna have only hydrogen on this, and here I have this group over here, this group over here, so it will be hard to extract this proton by a sterically hindered base. So we're gonna extract this proton over here, and so we're gonna have this as the major product, and this is Hoffman. Okay, there's another one, if he can grab, will be the minor in this case. So here will be the minor, and this is Zaitsev. Okay, so pay attention on the questions if you have questions on the test, and if you ask like elimination always favors Zaitsev, no. If the question is elimination E1 always favors Zaitsev, yes. But if it's only saying eliminations, you need to specify the E1, yes, will always favor Zaitsev, and most of the eliminations, both eliminations, will normally will favor the Zaitsev. But if you have a buck base and an E2, will favor Hoffman. Okay, so the reason for this is that it's easier for the buck base to access the protons that are not hindered by the other carbons, as I showed over here, right? We only have hydrogen as neighbor. Okay, so pay attention. When we have less substances, alkene is the target, and use a sterically hindered base. Okay, this is how we can predict it, the product. Okay, so if that is a question, how I could have Hoffman as my major. So in an E2, we just need a strong and a sterically hindered base. Okay, that's it. That's all.